This is section 14.3 on measures of dispersion, page 1. And the first thing we're going to do is read an example out of the textbook on batteries. So I'm going to go ahead, just in case you don't have your textbook, I'm going to put it up here so that you can see it. And I want you to pause the video and read this part, and then we'll discuss it. Okay? All right, so we're back. So what you learned about that is that we do need to measure data if we really want to understand what's going on with it. We need to measure it in more than one way. We can't just look at the center. We have to look at how spread out it is. So we're going to have different ways of doing that. And the first simplest way is called the range. So what is the range? It takes the largest data value minus the smallest data value, and it gives you a feel for how spread out the data is. So let's do an example of this. Here are our data values, and we want to find the range. So in this, the range we would say equals largest minus smallest. That's a good way to abbreviate it. All right, so what's the largest? As we run through here, it looks like nothing's bigger than 100. So we'll say 100 minus what's the smallest? 72 so far, 65, nothing smaller than 65. All right, so the range is 35, and that would be our answer here. Okay, in example 2, it says find the range again by replacing 89 with 29. So now, what is our data? So our data looks like this. We have 29, and then 72, 100, 87, 65, 98, 77, 92. Okay, so now the range is equal to, again, the largest minus the smallest. But we have a new smallest value. Our largest is still going to be 100, but our smallest is going to be 29. So that's going to equal 71. Okay. So the next question asks us, do outliers affect the range? Well, 29 is an outlier. If you look at all these values here, they're all, like 65 and above, and then you've got this very small value. Well, look at what the range is. Range is huge compared to the range before. So the answer is yes, they do. Okay, so then our question is, would that be a good way to measure how spread out the data values are? Well, when you look at these, you have this one oddball, but for the most part, they're concentrated in this area. So maybe this isn't the best way of measuring our dispersion. So we're going to think of another way. But before we do that, I want you to pause the video, go ahead and do your classwork problem on range, and then bring the video back up again. Okay, so we have a note here that says the range is the simple way to describe the spread of the data. Let's look at another example. It says the following distributions all have a mean and median of 5. If this data represents the number of ounces in a bottle that should contain 5 ounces, which distribution would you prefer? Okay, so if you're thinking about filling a bottle, okay, so it's supposed to contain 5 ounces. So most of them do, but some of them contain 4, some of them contain 6. Look here, most of them do, but we go all the way down to 3 and up to 7. Here, goodness, we go all the way down to 2 and up to 8, okay? So at this point, maybe we're overfilling and wasting product. And here, customers aren't going to be very happy when they only have 2 ounces. All right, so when we look at it, which distribution would we like? Well, I think we'd like the one that's most concentrated around 5, okay? So this is the distribution we would prefer. All right, let's take a look at definition. If X is the data value in a set whose mean is X bar, then X minus X bar is called X's deviation from the mean. So what are we doing? If we look at a picture here, remember we were told that the mean was 5, okay? And we look at this value of 4, okay? So we have a data value of 4. What do? We say 4 minus 5, and when we subtract that, we get a negative 1, which means that it gives us how far we are from the mean. Well, we're 1 unit from the mean, and because of the negative below. So here with 6, let's say, you would say you're 1 unit above the mean in the positive direction. when you say 6 minus 5. Okay? All right, so now the most important definition of the section, the standard deviation of a sample of n data values is, here's the formula. I know it looks bad, but let's talk about what we're going to do. We're going to make a table so it won't be too bad. We're going to first find the mean. Okay, so remember that's add up all the data values, divide by the number of data values. Then we're going to find every data value minus the mean. For each data value, we're going to do this, subtract the two. Then we'll square it. Okay, so notice here I want you to see, we're going to be making a table here. Okay, so you're going to put the data value in, then you're going to say data value minus the mean, and then you'll square it. Okay, so that's what our table looks like. And then once we do that, we're going to add all those values up because that's what that sum sign means, add them up. And then we'll divide by the quantity n minus 1, and then we'll take the square root. Okay, so that's our plan. Go on to page 2.